Hi everyone, let's start section 3.2 on logarithmic or log functions and their graphs. A key thing to remember is that logs are exponents. Logarithms are exponents. Let's say we want to evaluate log base 3 of 9. By the way, log base 3 represents a function, so more and more I like to put parentheses around the argument, the 9 here. All right, so some people call this the box method, where we set this equal to a box, which will contain our answer. And we're asking 3 to what exponent is going to give us 9. 3 to what exponent gives us 9. All right, let's go over here. Three to what exponent, the box, is going to give us 9? Well, 3 to the second gives us 9, and that's going to be our answer, our logarithm. Okay, so 2 is our answer. Log base 3 of 9 equals 2. That's the logarithmic form. When we did the zigzag, that was the exponential form. 3 to the second is 9. So mentally, I like to lower the 3, raise the 9, and I'm asking myself, 3 to what exponent is 9? The answer is the 2 here. Okay, let's do some more examples. We're going to think zigzag. Okay, got to be careful here. Okay, so log base 5 of 1/5 is what? So we can imagine a box over here. All right, 5 to what exponent is 1/5? Well, 5 to the negative 1 is 1/5. Erase all this. Five to the negative 1 is 1/5. Negative 1 is our logarithm. Next, let's look at this over here. Log base 9 of 3 is what? 9 to the what is 3? And this is going to be a little bit trickier. 9 to the what is 3? Well, how's 3 related to 9? 3 is the square root of 9. What's the square root of 9? It's 9 to the 1/2. 9 to the 1/2. So 1/2 is going to be our logarithm. Nine to the 1/2 is 3. The square root of 9 is 3. This bottom one is a trick question. 10 to the what is 10 to the 7th? 10 to the 1 is 10 to the 7th? Let's take a look at that. 10 to the what is 10 to the 7th. This is all a mess. Let me erase this. All right. 10 to the what is 10 to the 7th? Well, 10 to the 7th is 10 to the 7th. A horse is a horse. So the answer here is going to be 7, because a horse is a horse. 10 to the 7th is 10 to the 7th. This is a demonstration of an inverse property, because log base 10 and the base 10 exponentiation function are inverse functions. They undo each other. So the 7 here becomes the 7 over there. We've seen this before with things like cube root and cubing. Okay, so in our next video, we're going to talk about logs with particular bases, some special types of logarithms. So until next time.